Welcome to question release question number 13 for the California Standards Test for Geometry. It says which triangles must be similar. So similar, remember, means that all angles are congruent and all sides are proportional. So which one does that hold with? Two obtuse triangles. Is it possible to have obtuse triangles where not all angles are congruent? Sure. So this wouldn't be the case. I'll draw a quick picture of that just to prove that to you. So an obtuse triangle, you could have something like this. So this is a counterexample for part A. Any obtuse triangle has one obtuse angle. I could say this is 120 degrees, but I could make another triangle. It's still an obtuse triangle. This could be 150 degrees. This would not be similar to that because all the angles don't match up. All angles are not congruent. So it's not that. Two scalene triangles with congruent bases. Scalene means that all sides are different. So all sides, at least within the triangle, have different lengths. But if the bases are congruent, so we could have something like this and something like this. I'm trying to draw it so that this is a little bit longer than that. So that's saying that you have congruent bases, so something like that and that. But does that mean they're similar necessarily? No, I could draw another triangle like this and this. This could be scalene where these three are all different measurements, these three are all different measurements, but they're not proportional, the angles aren't all the same, they're not matching up. So not choice B. Two right triangles. I think that one's clearly going to be wrong, but let's check out a picture as to see why. So there's a right triangle, but just because right triangle is in that shape doesn't mean the other one has to be in that same exact shape or have the same exact angles. I could have one where it's more like a 45-45-90 triangle, and that angle wouldn't match up with that, that one wouldn't match up with that one. So not choice C either, but choice D, hopefully this is going to work because that's all we got left. Two isosceles triangles with congruent vertex angles. And so that would look something like this. We'd have isosceles triangles. This would be congruent to that here and here. Now it doesn't say that this one has the same exact measurement as this other one, but it does say that this angle is congruent to this one and that this one and this one have to be the same. And so there was a theorem that shows up in the similarity chapter that we went over called side angle side similarity. That makes that true. So if we use that theorem, choice D is definitely the right choice.